Welcome to part 3 of Introduction to the Unit Circle. Just to remind you what we've learned, we learned that if you have a unit circle where the radius is 1, the coordinates of any angle theta where the angle meets the circumference is always equal to the cosine of theta for the x value and the sine of theta for the y value. So if you were to complete an entire unit circle for going for 30-degree increments and by 45-degree increments, this is what you would get. And hopefully your teacher will have you complete a unit circle, but let's just see what some of this means. So for example, let's take this 150-degree angle, which is over here, and if I were to just outline that in green, as you see, and I were to just draw that, we notice this is a 150-degree angle, and if we find the coordinates of that point, which we have listed here, and we have it listed as negative the square root of 3 over 2 and 1/2, that tells us that the cosine of 150 degrees is negative square root of 3 over 2. It's got to be negative because it's in the second quadrant, and the x value is negative in the second quadrant. And the y value is 1/2, which is the sine of 150 degrees. That's going to be positive because that's in the y value is positive in the second quadrant. This final value over here you might see on the side is the tangent of 150. So using the unit circle, we can find the exact values, not the approximate decimal values, for the sine and cosine of all of our increments of 30s or increments of 45 in our unit circle, which basically gives us reference angles that are part of our special triangles. If you remember, our special triangles are 30, 60, 90, and 45, 45, 90. So this is a very valuable tool. So let's see how we could possibly use this. So here's a typical example. In this case, it says find the sine and cosine of 135 degrees using a unit circle, which is really saying let's find the exact values for the sine and cosine of 135 rather than plugging it into our calculator and getting an approximate value. First thing you want to do is you want to draw the angle. We certainly should be able to see that 135 degrees ends in the second quadrant. So we will put it about there. And let's draw our angle here. So this is 135 degrees. In order to find the sine and cosine, we need to find the reference angle in this triangle. So let's just drop a perpendicular. And we might notice that 135 plus 45 gives us 180. So that reference angle has got to be 45 degrees. And we know that the coordinates at this point will give us the cosine of 135 degrees and the sine of 135 degrees. And what we do is we look at our 45-degree reference angle. We know that to find the cosine of 135 degrees, we want to find the cosine of 45 degrees in the second quadrant. We know that the cosine of 45 degrees is the square root of 2 over 2. But notice in the second quadrant it is negative because the x value has got to be negative. Put that there. So now we know that the cosine of 135 degrees is equal to negative the square root of 2 over 2. To find the sine of 135 degrees, we need to find the sine of 45 degrees in this triangle. And we know the sine of 45 degrees is the square root of 2 over 2. And in the second quadrant, that would be positive. And therefore, now we know that the sine of 135 degrees is equal to the square root of 2 over 2. And if we want to find the tangent of 135 degrees, we would divide the opposite side. So if we wanted to do that, we could say the tan of 135 is equal to the opposite side of our 45-degree angle, which is the square root of 2 over 2, divided by the adjacent side, which is negative the square root of 2 over 2. And most of you should be able to see that's equal to -1. So that is a typical example of how you can use a unit circle to find the sine and cosine of various degrees. Why don't we try one more? So in this case, they want to find the exact values of the sine and cosine of 120 degrees. So we need to draw our angle. And 120 degrees would probably be somewhere about here. And there's a 120 degree angle. We'll want to drop a perpendicular. So let's do that. There we go. And this angle in here, we might know it's 120 plus 60 gives us 180. So we have a 60-degree angle. So all we need to do is find the cosine of 120 and the sine of 120 is to use our reference angle in the second quadrant. And in the second quadrant, we know that the cosine of 120 is equal to the cosine of 60, which is a half. But it's negative in the second quadrant, so we get -1/2. And the sine of 60 is a square root of 3 over 2. And that's positive in our second quadrant. And that immediately tells us the cosine of 120 is equal to -1/2. And the sine of 120 degrees is equal to positive the square root of 3 over 2. Let's do one last problem. So find the exact values of the sine and cosine of 225 degrees using the unit circle. So 225 degrees should be somewhere about here. And there's our 225 degree angle. What we want to do is find the reference angle, and you might notice the reference angle is 180 plus 45 will give us 225. In order to find the sine and cosine of 225, we need to find the coordinates of this point. We know that the cosine of, well, we have to drop our perpendicular, so let's drop our perpendicular. And so first we want to find the cosine of 225. And once again, that would be the x-coordinate. And our x-coordinate is equal to the cosine of 45 in the third quadrant. And we know the cosine of 45 is the square root of 2 over 2 in the third quadrant, but it's negative in the third quadrant. So we get negative the square root of 2 over 2. And so now we have found the cosine of 225 degrees. We want to find the sine of 225 degrees. We'll find the sine of 45 degrees in the third quadrant, and that is negative square root of 2 over 2 because the y value is negative in that quadrant. So we're finding the sine of 225, which is negative the square root of 2 over 2. And let's write this down. Sine of 225 degrees is equal to negative the square root of 2 over 2. And we are done. So now it's your turn. Find the sine and cosine of 330 degrees using the unit circle. Good luck, and see you again next time.